This is 8-6, solving quadratics by using square roots. So you guys have learned in the past that if you take a number and square it, this is the result. These are actually called perfect squares. In blue, what I did was I took the square root of those perfect squares, and the result are these answers. So the square root of 1 is 1, but I wrote plus or minus in front of it. That's what that symbol means. Square root of 4 is plus or minus 2. Square root of 9 is plus or minus 3. The reason why I said plus or minus is because a lot of people will say, okay, the square root of 25 is 5, which means that 5 times 5 equals 25. But in addition, negative 5 times negative 5 equals 25. So I have to say that it could have either been positive or negative. So the example that's provided in the lesson is the same idea. If you have 3 times 3, it's 3 squared. 3 squared is 9. The square root of 9 is 3. But the same thing with negative 3. If you have negative 3 times negative 3, well, that can be written as negative 3 squared. That equals 9. If you take the square root of 9, you could have had negative 3 to begin with. So therefore we write plus or minus 3. Now you could take the square root of things in your calculator, but you still have to know how to solve an equation. So here my x squared is isolated. Once an x squared is isolated, the last step would be to do the opposite of squaring it, which is square rooting it. It actually just crosses out the square. And you square it the other side. And so my x is equal to plus or minus, and the square root of 169, if you use your calculator, if you have it memorized, is 13. Now you can't take a square root of a negative. So in this next one, I'm going to try to isolate x. I take the square root of a negative. There wasn't any number multiplied by itself that results in negative 49. Like 7 times itself is positive 49. Negative 7 times itself is positive 49. So they can never have a negative inside the square root. So therefore this one is no solution. Go down to example 2. Again, you have to isolate the x squared first, just like you would have to isolate an x. You can just pretend it's an x at first. So I would subtract 7 from both sides. I get x squared equals 0. Then I take the square root on both sides, and x is plus or minus 0, but 0 is not positive or negative, so in this case we just get to write 0. Okay, next one, isolate the 16x squared. So I add 49 to both sides. I get 16x squared equals 49. I'm going to divide both sides by 16. Since I noticed that both of these are perfect squares, I'm not going to actually divide it. I like fractions better anyway, but I just want to show you why I'm not going to divide it. If you keep x squared equals 49 over 16, and then you go to take the square root, you can actually separate this into square root of 49 over square root of 16. It's really the same thing, a large square root or an individual square root. And so we end up with plus or minus 7 over square root of 16 is 4. So it's a simplified fraction, so we can leave it just like that. Okay, in this next one, we can't isolate x first because we have this group of parentheses. It stays together. So to get rid of the squared, I have to square root. So then I have x minus 5 is equal to the square root of 16. Well, that's plus or minus 4. So I'm going to have to write two equations right now. I have x minus 5 could have equaled 4, or I have x minus 5 equals negative 4. It's sort of like when you learned absolute value equations. So I have to solve for both of these possibilities. I get x equals 9, or x equals 1. And we can write that in our solution set if we want to for all values of x such that x equals 1 and 9. Okay, here it says when solving quadratic equations by using square roots, you may need to find the square root of a number that is not a perfect square. So not that list like 1, 4, 9, 16. In this case, the answer is an irrational number. So an irrational number is the square root of a non-perfect square. So square root of 64 is 8. That's rational. But the square root of 60, well, that's going to give you a decimal. It's about 7 point something. And so that makes it an irrational number. So when we're solving, if we take the square root of the x squared to isolate the x, then we end up with plus or minus radical 15. Well, it's an irrational number, so if I'm asked to round to the nearest hundredth, then I would say that it would be plus or minus 3.87. Okay, next one. Here's my x squared, but I have to get rid of the 90 first. So I have negative 3x squared equals negative 90. Now, just like if this said negative 3x equals negative 90, my next step would be to divide both sides by negative 3. So you have to fully isolate the x squared first. Negative 90 divided by negative 3 is 30. Now to cancel the square, I'm going to square root both sides. So get x equals plus or minus radical 30. But then if I round that to the nearest hundredths, then x is approximately, that's an approximately symbol if you want to use that, plus or minus 5.48. Okay, for this I drew a picture of what is stated here. So we have a rectangular garden. The garden is twice as long as it is wide. So for the width I put x and the length I put 2x. It's going to be twice as long. And I know that it has an area equal to 578 feet squared. Remember, area comes from length times width, or base times height, for a rectangle. So, since I know that A equals LW, I can plug in my values. So I know that A is 578 feet squared, or 578, just to make things easier here, is equal to length times width, but I know the length and width. The length is 2x, and the width is x. So I'm going to get 578 equals 2x times x. Remember, when we multiply, we add exponents, so that's 2x squared. Then start isolating the x squared, so I divide both sides by 2. So I get 289 equals x squared. To officially isolate x, I have to get rid of that squared, so I square root, and x is equal to plus or minus 17. But in a real life problem, we wouldn't have a negative measurement for a length of a garden, so I know that x really is 17 feet. And the question said, what would be the length? Well, then the length, since it's 2 times x, then that's going to be 2 times 17 feet, so the length is 34 feet.